In this lecture, we're going to take a sort of brief interlude before we get into more details on the free radical halogenation reaction. I want to talk generally about a class of reactions that is important enough to deserve at least to deserve a lecture on its own, even if we make a short video as a result, which, you know, I've heard nobody really complains when I make short videos. So what I want to mention, and this is related to the free radical halogenation reaction, is that the free radical halogenation reaction proceeds by a special type of process called a chain reaction. So the free radical halogenation is an example of a chain reaction. A chain reaction. And so I want to take a second to just outline what kind of constitutes a typical chain reaction. Maybe you've heard this term chain reaction or chain event before, but chain reactions have 3 stages. And it's important for us to know each of these stages. We have initiation, propagation, and oh goodness, 1 is initiation, 2 is propagation, and 3 is termination. Okay, so these steps, the way that chain reactions work is chain reactions do the 3 stages over and over again. Actually, they do the 3 stages, but let's do this. But stage 2 happens over and over until the limiting reagent is fully consumed. Okay, so we're going to do this whenever we do a chain process. It just happens over and over and over again until the limiting process is consumed. But what I want to point out is that stage 2 is really the most important part of the chain reaction. The initiation and the termination the initiation sets us up to begin propagation steps. And termination is just generally an undesired outcome that kills the chain reaction process. But let's go ahead and get into these steps in a little bit more detail. So for a free radical chain reaction, and it's the free radical halogenation, I just want to make sure I spelled something correctly. Sorry. Okay, yeah, good. Sorry about that. For a free radical chain reaction, what we do is halogenation chain reaction, we take in step 1, which is initiation, we're going to have some starting material and generate some intermediates. And this is actually true of any initiation. The stuff that we put into the bottle during the initiation step will form intermediates. In our case, we have some starting materials that have no free radicals, and we apply heat or light to initiate the reaction, and that forms 2 times free radicals. So we go from 0 free radicals to no free radicals. We get 0 reactive intermediates to multiple reactive intermediates. So in general, a chain process will form reactive intermediates, things that can undergo the reaction as a result of the initiation step, from things that you have in a bottle lying around that are generally a bit more stable, our starting ground state structures. In the case of free radical halogenation, we start with 0 free radicals and we go to 2 free radicals. And we'll look at the details of the mechanism in the next lecture. Okay. Then in step 2, which is propagation, we go from intermediates that are reactive, intermediates, and generally starting materials. So we have some things that we can put into a bottle and intermediates, and we go to products plus intermediates. Now, one thing that is often a misconception when you're understanding chain reaction processes is that people interpret the last step, which has termination, as that step that forms the products. Generally, that's not true. Generally, a good chain reaction event will form products during the propagation step. That's the step that keeps churning over and over and over again until the limiting reagent is consumed. So what we're going to do is take some starting materials, and in this case, for our free radical halogenation of alkanes, the alkanes will be the starting materials, and the intermediates will be our free radicals. And we'll discuss what these are next time. So alkane plus X2 reacts with free radicals to form products, which are our haloalkanes, and intermediates, which are free radicals. In a propagation event, you have the opportunity to form products. Opportunity. It doesn't happen all the time. Actually, what we'll see is in this mechanism, there are multiple types of propagation events that can happen. But the thing that is consistent of any good propagation event, which I'll highlight in yellow, is that you have yellow intermediates on either side. So in a propagation, any propagation step, we're going to have our reactive intermediates on the left and different, but also reactive intermediates on the right. So left and right both have reactive intermediates. That defines a propagation step. The initiation step was defined as 0 reactive intermediates on the left and multiple reactive intermediates on the right. Now this is the step that keeps, the propagation is the step that keeps going. Termination, in termination, we take intermediates and we go to a state where there are no intermediates. It's kind of vague. What I will point out is product can form, but we typically don't like to form product here because that leads to a complicated mixture of products being formed. So let me just emphasize again, in chain reactions, we like the product to be formed during some propagation step. There could be multiple propagation steps. There also could be multiple possibilities for termination steps. Some form products and some don't. The key thing is the number of intermediates. So to understand the difference between initiation, propagation, and termination, the 3 stages of a chain reaction process, we have to be able to predict or just kind of know how many intermediates are going to be on the left and the right as a result of these processes. No intermediates to intermediates is initiation. Intermediates on the left and intermediates on the right could be is then a propagation step. And then intermediates forming no intermediates, or the consumption of intermediates to give things that are no longer reactive, that's termination. What I'll point out is termination is required. It's going to happen when you shut off the light bulb or turn down the heat, okay? But it is often undesired. That is, before you're done consuming your limiting reagents, termination events are typically frowned upon. We don't want to see them. We want to see as much propagation as possible because it's in the propagation events that we have the best opportunity to form product and continue the cycle onward. So this lecture is a little bit more philosophical about chain reactions, but I think it's good to keep these ideas in mind before we jump into what's actually a fairly complicated mechanism, and that's the free radical halogenation of alkanes.